So they say consider the following cone which has a volume. So the volume is given here. So this cone can occupy a volume of 1005.31. And they are also saying which is the area, the height. The height of this cone is given as 15 centimeters. Now we can go and highlight the given information to say, okay, what is it that we have? So we have the height, perpendicular height. So height starting from here to here, they tell us with this one here, it's 15 centimeter. And then they say, which, okay, but now we also have the volume. So this thing here, this thing can occupy 1005,1,31. Now, unlike the one that we're doing before, the one that Pasatana was doing, we knew what was this and we knew what was this, and then we could get R. So in this one, if we take out the right angle triangle, on our right angle triangle, we know what is this one. This one here, it's 15 centimeters. But we don't know what is this side. We also don't know what is this side. Yeah? And then we know if we're using trigonometry, if we knew what was this angle or we knew what was this angle, we could get the other side. But we don't know them. Yeah? So first thing first, they say which we should write down the formula. Write down the formula for the volume of a cone. What is the volume of a cone? Number one. So volume is going to be given by 1/3 again, multiplied by pi, multiplied by r squared, multiplied by what? By h. Yeah, and then for you to know how to determine the formula for a of a cone, they will give us 1 mark. Number two, they say determine the radius. What is going to be the radius? Now, irradius here, as I was saying, irradius, it seems as if it's this side. We don't know what is this side. We also don't know what is this side. How are we going to get it then? We're going to use the volume. If we use the volume, I can already know from the volume to say, what is the volume? The volume is going to be given as 1005,31, which is going to be equaling to 1/3 multiplied by pi, multiplied by r squared, multiplied by, we know what is the height. What is the height? It's 15 centimeters. We want to get r squared here. What do you propose I do here? Why I didn't use Pythagoras, guys? I repeat again. I couldn't use Pythagoras because I don't know what is this. I also don't know what is this one. But I can use the volume here. So I want to get r here. How am I going to get r? I divide by 1/3, multiplied by pi, multiplied by what? By 15. Even this side, I divide by 1/3 multiplied by pi, multiplied by 15. And you see 1/3 will divide 1/3. 15 will divide 15, pi will divide pi, and then I'm going to be left with what? R squared. And then if I simplify this a little bit further, what do I get for that? It's 14,000. So I have 1005,31, 14,400, 14,000. 64,00, like this. Okay, and then you divide by r. You are giving it to us as pi. Now, if you put this one 64,00, you say square root, it says r is going to be given as what? As 8. And then this is going to be 8 centimeters. We take the positive one, a square root has a plus and a minus, but we take the positive one because we're dealing with length. So here we have what? 8 centimeters. Let's come and update our diagram. Here we have what? We have 8 centimeters. Okay. Huh? Yeah, we have two sides, man. Now that we have two sides, they say determine the slant height of the cone. Can we get this one now? How do we get that one? We can then use Pythagoras. Okay? Yeah, Tina, from the formula that we use, it depends. You can use S or you can use N. So I'm going to tell them which L all squared is going to be given as 15 all squared plus 8 all squared. And then you say root, it says L. This is small letter L, slant height. Our slant height is going to be given as, I think, 17. You get 17 centimeters. And then for this one, they will give us 1, 2, 3. We're still fine. And then we go to number 4. On number 4, they say determine the lateral surface area. So they want the surface area of only the cone. They don't want the surface area of the circle and the cone. Because you will realize after that they say determine the total surface area. Surface area, you have the area of the circle, you also have the area of the what of the cone. So if they say determine the lateral surface area, which is equal examination, they won't come up with terms that are going to tell us. They will tell you calculate the surface area of the cone. Calculate the surface area, the total surface area. Usually they will just say calculate the surface area. So let's start with this one of the cone. What is going to be the area of the cone? That's number 4. What is the surface area of a cone? The surface area of a cone is given as what? It's pi RL. And then we know what is pi R. We know it's 8. And then we just got this one as what? As 17. They say we should write it in terms of pi. And then this one is going to give us 136. 136 pi. Now, we can say this is going to be centimeter squared. Number 5, they say to determine the total surface area. How to determine the surface area? It's going to be surface area of a cone is going to be given by second, which is pi R squared, plus pi RL. And then some of these things you can see with our formula because we've been doing it. Now you start to remember them. Yeah, the more you do them, the more they will start to make sense. You don't have to always go and refer. So we have pi multiplied by 8 all squared plus we have pi multiplied by 8 multiplied by 17. This one gives us 64 pi. This one gives us 136 pi. All in all, we're going to get 200 pi, which is going to be what? What is 200 pi? 628.32. This is going to be centimeter what? Squared. And then you're going to get 1, 2, 3. Now, let's get to this interesting part, number 6. On number 6, they say determine the volume of the cone if the dimensions are multiplied by a constant of 2,5. Now, if we take the volume of this cone, what is the volume of this cone? Let's go and check. What is the volume of a cone? What is the volume of this cone? Yeah, okay. What is the formula to calculate a cone? The volume of a cone? It's 1/3 pi R squared multiplied by what? By 8. They say which you are going to increase radius by 2,5. You're also going to increase the height by 2,5. Now, if you increase the radius and then you also increase the height by 2,5, what is going to happen then? It means that you are going to have this thing here, which is going to be 2,5 all cubed. How did I get 2,5 all cubed? It means on the volume, remember, here, I'm supposed to have something like this. Again, this is pi here. Let me write this with a different color so that you'll remember. Instead of R, what am I going to put here? I'm going to put R multiplied by 2,5. Okay? So this is going to be 2,5 R all squared. Multiplied by, this one is H. Instead of having H, what am I going to have here? 2,5 multiplied by what? By H. Now, what is this thing basically? It's 2,5 all squared and 2,5. 2,5 all squared. It means which is going to be 2,5 to the power of 3. So what is going to be the new height? The simplest way to do this thing here is going to be used to say something like this. The new height is going to be like you check the sides that you have. So you have side number 1, you have side number 2, but the other side is squared. So for you to get the new volume, you're going to say which is 2,5 all cubed multiplied by the old volume. What was the old volume? The old volume was 1,005,1,31. Then this is going to be the new volume. Does it make sense, man? Yes. Yeah, and then you say 2,5 all cubed. How did I get 2,5? The trick is here. Because we increase R. We're not going to increase R by 2,5. We're going to increase it by 2,5 multiplied by 2,5. But H was simply going to increase it by what? By 2,5. Then it means you had 2,5 3 times. 2,5 to the power of 3. And then the volume, the old volume, it's still going to be exactly the same multiplied by this 2,5 all cubed. What you get if you type this new? 15,797, pi. And then this is going to be centimeter cube. Yeah, here's your homework. Wait for it. Activity 2. You are doing number 1. And then you're also going to do number 2. I did send this thing.
1 and 2.
Yeah, 1 and